Hello everyone, I hope you can all see me and hear me. We're doing this on YouTube, so I just want to make sure that our audio, video, visual, everything is spot on. I want to make sure that the tech is working fine, that you can see me and hear me clearly, that you can see this board which says PiMO class 5 and 6. And I hope you've all had a good Sunday morning, enjoyed yourself, ready for having some good fun discussions on mathematics. I know you've all taken this exam with enthusiasm, so you're bound to be looking forward to the results, which is good. It's always, some curiosity is always there. When you write an exam, you want to know what the numbers are, what the marks are. Right? So, but that's not this session, what this session is all about. We will get to that. You can check out the scores sooner or later. We're going to discuss these questions. These questions are a lot of fun. They are atypical, different. So they're slightly, how do I call it, wacky. It's always more fun. The regular thing is the regular thing. The slightly non-regular, different thing is the more fun thing. So therefore, it is more exciting to do something out of the ordinary, which is what we're going to do. We're going to solve all 10 questions completely, with possibly discussing all kinds of new methods. We're going to have fun doing that. I want all of you to, if you have any questions, put them on the chat window. We will discuss. At the end of it all, we will have a huddle to discuss all outstanding questions as well. Wonderful. Audio, video clear. Thanks, Krishan. I'm just looking at the chat window. Tirumurugan saying excited. I am excited too. And Nukula's sister saying I wrote the exam 2 times, which is good. There's a bit problem in the audio. It was more fun. If there is a problem in the audio, I will just check that. Audio is noisy. Let me just check that. I will see if I can improve that. Give me a second. I'm going to fix this. Hello. I've done some minor tweaks. Hopefully that should work. I'm going to reduce the ambient noise as well. Hopefully that should also help. Hopefully this will remove all kinds of noise problems that we have. Several of you are saying exam was easy. Of course it was not easy. I took the exam. I went through all the questions in the exam. I prepared a bunch of these tests. I went through the solutions. The exam most definitely was not easy. And so those of you who are saying it was easy, either you're done it exceptionally well, or it's quite possible that you thought it was nice and easy, but it was not that easy either. Right? So I know all of you are excited to say, hey, now it is easy, brilliant, which is nice, which is happy. I like it when people say questions are easy and fun and solvable and all that. But it was not that easy. It was definitely not that easy. Right? That I know, that much I know. It's working all right. The volume is better now. Thank you. It wasn't easy. Manimala is saying, Nirja Gopinathan saying it wasn't easy. It wasn't easy at all. I can tell you that much. I've taken this exam as a 10-year-old, 11-year-old, not so many. Now I have more. When we were younger, these exams are not that common. I've taken these exams when I was older. I've taken this exam, like you guys. I did not find it easy. And I've been teaching math for 20 years. So it is definitely not easy. Fun, it was definitely fun. There's somebody who said it was not easy, but it was fun. But it was definitely fun. It was okay. Come on, Purnima Rathore. You can say better than okay. So, bland. It was not bland. A lot of questions were really thrilling. It was hard, definitely hard. Very hard, not easy. Very easy at the second attempt, yes. It's called the power of hindsight. Right? So a lot of our leaders also find things very easy on hindsight. It's so much fun to say this is exactly what you should have done in 2020 June. And then some people add it up with I told you so. You told me so now. 1 second, we're having some issue technically. I'm just going to fix that. There is some sound is what I'm being told. I'm going to fix it. At least I'm going to try to fix it. Or I'm going to pretend to Try to fix it. Let me see. You don't have any easy mechanism. I'm going to live with that. Maybe, is it loud? The volume is fine? Okay, okay. Is it this? Okay. Sorry, folks. We're just trying to fix all the paraphernalia around us to make sure that the noise, ambient noise, is as low as possible. It should hopefully work. It should hopefully work. Put your headsets on. The PPT is going to talk for most of the time. I'm going to jump in. I'm at my happiest when I'm teaching. I'm teaching math with young kids. So you're there. The math is there. The questions are fun. So I'm going to have a great time. Lovely. We've gone up to 10.5, but I'm going to jump in and have a crack. Lovely. Let's do this. Find x plus y in the given figure. Wonderful, wonderful question. First of all, there are several points. It is clear that these points are equally spaced. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 points around this. And there are 12 points kept around a circle. And then we want to find angle x and angle y, and then we want to add these up. Right? Lovely. So this is a nice circle. There are 12 points around it. The first thing to note is the total angle around a point is 360 degrees. So I look at this question and say, hey, there are 12 points here. It's like the 12 positions in a clock. And so this is could be 1 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5, 6, all of them. So there are 12 points. What are the angle between any two R positions that are adjacent to each other? What is this angle? What is this angle? This is 30 degrees. Why? The overall angle around a point is 360 degrees. So one angle, between any two adjacent points, that is 30 degrees. That's all we need to know. We're through with this. How are we through with this? We want to find x from A. This is 1, 2, 3, 4. So this angle here is 120 degrees. Why? 30 plus 30 plus 30 plus 30. 30 plus 30 is 60, 90, 120. Nice. Likewise, I to G, there are two parts here, 30, 60. Between any two, the angle is 30. If you skip one, this angle will be 60. After this, we are through. How are we through? This AOE is an isosceles triangle. Why? This is the radius, this is the radius. So this is x, this is also x. In an isosceles triangle, two sides are equal, two angles are equal. Three angles in a triangle add up to 180. That we know. This is 120. The other two should be equal and add up to 60. Totally it is 180. 120 is gone. Remaining is 60. 60 should get split as 30 and 30. Exact same idea here. This is 60 degrees. These two are equal. Radius and radius. That is why. This is why. One angle is 60. The other two should add up to 120. Why? Sum of all three angles is 180. 60 is taken away. These two should add up to 180 minus 60. From 180, we've accounted for 60. Remaining is 120. 120 is two equal angles, y and y, or y should be 60. Y should be 60. X is 30 degrees, y is 60 degrees. We've got ourselves 30 plus 60 equal to 90 degrees. The one thing I liked about our PiMO this time is the question started nice and easy, and then slowly went up in level of difficulty, which is how it should be. It should be the more challenging one should come towards the end, right? Lovely, 90 degrees, right? So between any two adjacent positions on a clock, the angle is 30 degrees. Between 8 o'clock and 7 o'clock, this angle is 30. This is 30. So what we're doing here is thinking about it like the clock. So this angle in the middle is 120, 30 and 30. Isosceles triangle, two angles are equal. The angles opposite to the two equal sides will happen to be equal. Brilliant, 90 degrees, we're done with that. I'm just having one look at the chart. Let's go to the next one. What is the least positive value of the expression? 2050 minus EIN minus ST minus EIN, where each alphabet stands for a distinct non-zero digit. That means E could be anything from 1 to 9. I could be anything from 1 to 9. N could be anything from 1 to 9. S could be anything from 1 to 9 and so on. I want this to be as small as possible. From 2050, I'm subtracting this and I want that subtracted thing to be as small as possible. Or I want EIN plus ST plus EIN, this to be as high as possible. As high as possible. I'm subtracting this. From 2050, I'm removing something. Then I want the remaining to be as small as possible, or what I am subtracting should be as high as possible. The moment I write it like this, I say, hey, this is very silly. I should not write it like this. Why? 3-digit number. It's a 3-digit number. It's a 2-digit number. I'll get confused. This is a 2-digit number. I should make sure that my hundreds and tens and units are all proper. I shouldn't put S here. I should say, hey, EIN ST. Right? So I'm writing EIN right next to each other because it repeats. It makes our life easier. Right? So now the question is done. Why? We want this to be as high as possible. We should put maximum digits 98765. EIN should be 987. ST should be 65. Why are we doing this? Because we want our digits to be as high as possible. So obviously the number should not be maximum. The hundreds place should be high. I should not put 789, I should put 987. So E should be 9, and then immediately best case scenario 8, best case 7, 6, 5, 987, 6, 5. This way my total will be as high as possible. I'm very happy. I want the hundreds place to be the maximum digit, tens place to the maximum available after that, units place to the maximum available even after that. Put this as 9, put this as 8, put this as 7. And 6, 5. Is this correct? No, it's not correct. It's not correct. Why? Because I put 9, 8 and 7. 9, 8 and 7. EIN is very high. But because I put N as 7, I'm not able to put S as 7. I want, this is in the tens place. That is in the units place. This doesn't help me. 9, 8, 7. Here the 7 gets counted as 7. This 6 gets counted as 60. The tens place number is going to have a massive impact compared to my units place. I should not put 987. I should say, hey, 9 for the hundreds digit, 9 for the hundredth digit, then 8 for the tens place, then 7 for the tens place for S, then 6, 5. This is going to be my best case scenario for EIN, ST, EIN. Only 5 digits. I'm only thinking in terms of 9, 8, 7, 6, 5. The maximum, there are only 5 digits here. So I need to accommodate 9, 8, 7, 6, 5 within EIN, ST. One thing is very clear, E has to be 9. Why? It's in the hundreds place. And then we come to the tens place. In tens place, we have EIN, ST. This I sits in the tens place, this S also sits in the tens place. So put an 8 and a 7. Then we come to the units place. Best possible 6, 5. I put 2 6s and 1 5 because 6 is greater than 5. I would rather use it 2 times instead of 1. Now I add all this up. 6 plus 6, 12, plus 5, 17, 7, 1, 9, 17, 24, 4, 2, 18 plus 2, 20, 2047. The maximum possible sum of EIN plus AIN plus ST is 2047. The minimum possible there, 2050 minus 2047 is 3. The smallest possible. It's absolutely delightful question. All we are saying is take the digits available, put the highest possible in the hundreds place, then whatever is free, highest possible in tens place, then whatever is free, highest possible in units place. And then shift key, make sure that the digit that appear twice is 8 and only once is 7. Twice is 6, only once is 5, and then do the math. And wonderful question, answer is 3. Lovely. Let's go to the next question. Hopefully that's also fun. David has a drawer containing 7 blue balls, 21 red balls, and 17 green balls. The drawer. Blue, he has 7 of them. Red, he has 21 of them. green, he has 17 of them. After adding more red balls, Dravid noticed that there is now a 60% chance that a ball randomly selected from the drawer is red. Nice. So now first let's think about how many are there. 7 plus 21, 28, 17, 45 balls are there totally. Right? He's saying removing a ball randomly from this set, it's a 60% chance that it will be red. Nice. If I remove randomly from here, there will not be a 60% chance that it is red. Why? It's 45 out of 45, 21 red balls. So it's basically saying the proportion of red balls inside is 60%. That's what this question says. 21 by 45 is not 60%. 21 by 45 is less than half. Half is 50%. There's more than, it's not. So right now, this ball does not, this box does not have 60% red balls. I have to add a few red balls to slowly increase the share of red balls. I need to add red balls to take the share of red balls to 60%. That's what I want to do. How many am I adding? Maybe I'm adding R of them. I add R red balls to make sure that my share of red balls increases to 60. Right now it's not 60, I want it to be 60. I want to take it to 60%. So I can think about R and then simplify. I don't want to do that. I want to do this differently. Right? So share of red equal to 60%. What is share of others? The other two, that will be 40%. We have blue and green. If red has to be 60%, the other two will have to be 40%. Nice. I'm not thinking about red. I'll come to it later. I'm adding some red balls. I'm not adding any blue or green balls. Finally, I know in my box, 60% of the balls are red. That means 40% are blue or green. How many blue or green are there right now? Blue plus green equals 7 plus 17 equal to 24. Nice. There are 24 blue and green balls. This 24 represents 40%. So this 24, this corresponds to 40%. The red balls account for 60%. Remaining 40% should be blue or green. These 24 balls are there, that accounts to 40% of the total. Or 24 goes with 40, most goes with 100. 40% of something is 24. What is the 100%? What is the total thing? That's what we want to find. Or we can do it even better. We say, hey, this 24 is 40%. What will be 60%? That's all we want to find. 40% of something is 24. 40% of something is 24. Or 20% of that thing is 12. Half of 40% is 20%. Half of 24 is 12. 40% is 24. 20% is 12. 60% be 12 plus 24, 36. So blue plus green is 40%. This is 24. Red is 60%. Should be 36. Or my box should contain 36 red balls. How many do I have right now? I have only 21. I have 21. I should add something to make it 36. How many am I adding? I'm adding, if I add 10 more, I'll get only 31. I want 36. Or I'll add 15 more. To this 21, we add 15 more to get 36 red balls. If I have 36 red balls, the red balls will constitute 60% of the total. The remaining will constitute 40% of the total. I'm interested in making sure that red balls are 60%. I go about it by saying the remaining has to be 40%. 24 balls remaining, that should be 40%. If 24 balls is 40%, what is 60%? 36 balls. I should have 36 red balls. I already have 21. I'll add 15 more. Excellent question. Lovely. I'm going to go to the next question. Having a look at the chat window, some of you are saying you didn't understand some one question. This video is going to be there forever. Just rewind there, have a go at it. You should be able to, if you go through one more time, you should be able to have a grab at it. If you don't do it right now, because then you'll miss the next question. Advantage of learning on on a video interactive format is you can pause the teacher, rewind it later on and then go through it. Or go with the teacher, forget that question, attend everything else and then come back and revisit that question later on. Wonderful. Wonderful. I'm going to go to the next question. Abraham, Bharat, Chirag and Damodar stand in queue. A, B, C, D. I'm going to make it A, B, C, D from now on. Abraham does not want to be first. And Bharat does not want to be immediately after Chirag. In how many ways can they stand in a queue? And so A, B, C, D, they stand in a queue. Something like this. A, B, D, C. This is not possible. Abraham doesn't want to be first. And Bharat does not want to be immediately after Chirag. C, B, A, D. This is also not possible. Right? Starting with B, then going to D, then A, then C. This is possible. First of all, we need to understand the question. Right? So, we cannot start with Abraham. Bharat does not want to be immediately after Chirag. So, A dash dash dash, this is out. At any point of time, Bharat immediately after Chirag, CB, this is out. We cannot have a CB in the sequence. Bharat immediately after Chirag, we cannot afford to have that. And we cannot start with A. Both of this we know. Lovely. In how many ways can they stand in a queue? Very simple. We're going to do what is called brute force counting. Most juiciest, my favorite method of counting. Brute force. What is brute force? I'll write everything. I'll just take a big bazooka, do brute force, no mathematics, no fancy formula, nothing. I'll write everything and count it. I'll be smart about it. I'll be intelligent about it. I'll apply my brain about it. I'll use good techniques about it. But I will count everything. Brute force. No fancy tricks. And so, what could the first one be? First one cannot be A. First one could be B. First one could be C. First one could be D. So A standing first, we are eliminating straight away. Right? We know Bharat does not want to be immediately after Chirag. Immediately after Chirag, Bharat cannot be there. So this one, Bharat is first. So Bharat cannot be immediately after Chirag, is already taken care of. Right? So now, what can be this second chair? Second slot could be BA. Second could be BC. Second could be BD. The first two could be BA, BC, BD. First one is B, second could be A, C or D. All three are valid because we cannot have a CB, we can have a BC. With BA, what could it be? BA, CD, BA, DC. Both are possible. With BC, what could be? BC, AD, BC, DA. Both are possible. With BD, what is possible? BD, AC, BD, CA. Both are possible. There are 6 possibilities. Starting with B. Now let's move to C. If we start with C, the immediate next person cannot be B. Because CB is ruled out. We cannot have a CB. So what could this be? This could be CA or CD. We could have CABD, CADB, CDAB, CDBA. 4 possibilities. Now what do we do? Now we go to D. Now the first one is D, second could be A, B or C. I'll put all. I could have DA, DB, DC. Starting with DA, I could have DABC, DACB. But hey, I cannot have CB, so this DACB is ruled out. Starting with DB, I could have DBAC, DBCA, both are fine. Starting with DC, I could have DCAB, DCBA. I cannot have DCBA because there is a CB in between. This is fine. Once again, we have 4. We're done. Starting with B, there are 6 possibilities. Starting with C, there are 4 possibilities. Starting with D, there are 4 possibilities. 6 plus 4 plus 4, 6 plus 4, 10, 10 plus 4, 14. We are done through. And excellent. A lot of these questions, there's lots of formulae that you will learn later on, but this method is super robust. You write down a bunch of these things, You know why you are eliminating everything starting with A. You know why you are removing of the CB possibilities here. By the time you come here, you already be careful. Starting with A, D, there could be something with CB that I need to worry about. DACB and DBCA, sorry, DACB and DCBA, both we need to worry about, both we'll remove. We cannot start with A, we cannot have a CB in between. That's it, everything else can go as it is. Right? Wonderful. So 14 outcomes are possible, not 12, not 16, 14. Right? Wonderful question. Let's go to the next one. Oh, this is a nice question, challenging. Right? N factorial is 1 into 2 into 3 into 4 till n. 2 factorial is 1 into 2, 2. 3 factorial is 3 into 2 into 1, 6. 4 factorial is 4 into 2 into 3 into 1, 24, and so on. We know that 7 factorial into 13 factorial is 24 into k factorial. Find k. Very interesting. And so 7 factorial is 1 into 2 into 3 into 4 into 5 into 6 into 7. 13 factorial is 1 into 2 into 3 into 4 all the way to 13. 24 to 1 into 2 into 3 into 4 all the way till k. What am I going to do? Then I'm going to say, hey, this seems like an interesting question. Nice tough question. So I'm going to see, will k equal to 1 work? K equal to 1 won't work. This is 24 into 1. This has 1 into 2 into 3 all the way till 7. 1 into 2 into 3 all the way till 13. K cannot be small. 1, 2, 3 not won't work. Suppose I put k equal to 10. Let me just put 10. Suppose 1 into 2 into 3 into 4 into 5 into till 10. Suppose I had to solve this like an equation. What will I do? 1 into 2 into 3 into 4 into till 10 that side. 1 into 2 into 3 into 4 into 5 into till 10 this side. I'll cancel that off. Then deal with the remaining. Fine. Now, that doesn't work because if I put k equal to 10, I'll cancel till 10, then 11, 12, 13 are remaining here. And 1, 2, 3, 4, 5, 6, 7 till 7 are remaining here. On that side, there's only 124. K equal to 10 will not work. What am I going to do? I'm going to put k equal to 13. I don't want to have this fellow remaining. Cancel him off 30 completely. So I'm going to put k equal to 13 and see where that takes me. Right? So this will be 1 into 2 into 3 into 4 till 13. So what will I do? This whole thing will get cancelled with this whole thing. I have 1 into 2 into 3 into 4 into 5 into 6 into 7. This side is 24. This doesn't work. Why? 2 into 3 into 4. This itself is 24. And then we have 2 into 3 is 6, 6 into 4 is 24. And then we have 5, 6, 7. This is a very large number. That is very small. So my k is not 13 either. K should be more than 13. That is beautiful. Because now what will I do? I will put k equal to 14. 1 into 2 into 3 into 4 into 5 into 6 into 7 this side. 1 into 2 into 3 all the way till 13 this side is 24 into 1 into 2 into 3 all the way till 14. I'm going to try 14. 13 didn't work. What will happen? Everything till 13 will get cancelled. And then 14 will be remaining. 14 is 2 into 3 into 4 is 24. That is gone. What is remaining is 5 into 6 into 7. 6 into 7 is 42. That side there is a 14. This is 42 into 5. 5 into 42. 14 will get cancelled, but there is still something remaining here. Even 14 doesn't work. I have to go higher than 14, but I've got my answer straight away because this is 5 into 42. So rewrite this 1 into 2 into 3 into 4 into 5 into 6 into 7. 42 I can write it as 14 into 3. 5 into 3 is 15. 15 into 14 is what this will become. Now I've got going. I know that 1 into 2 into 3 into 4 into 5 into 6 into 7. This can be written as 24 into 5 into 3 into 2 into 7 into 15 into 14. After the 7 factorial, we have 1 into 2 into 3 all the way till 13 into 13. This side we have 24 into 1 into 2 into 3. We put all the way till 15. Then what will happen? It's beautiful. 1 to 13 will get cancelled. 1 to 13 will get cancelled. Just go away completely. What will we have remaining here? 24 into 14 into 15. What do we have here? 24 into 15 into 14. The key thing is to say our k should be more than 13. Therefore, straight away everything from 1 to 13 I'll cancel. So I'll have to say k should be more than 14. So effectively this question becomes 7 factorial equals 24 into 14 into 15 into something till k. And then we notice if we put 14 into 15 this works. 7 factorial is 1 into 2 into 3 into 4 into 5 into 6 into 7, which is 24 into 14 into 15 all the way till k. 24, maybe we can put 1 into 2, 2 into 3 into 4, or we can cancel 6 into 4. 14 is 2 into 7. 15 is 3 into 5. Done. K can go only up till 15. K equal to 15 works. Done. Excellent, excellent, excellent question. Beautiful question. One of my favorite. So answer k equal to 15 works. Now have one look at the chat. Kumar may be saying I have 4 wrong, but I understand your answer. That is the best thing to be in. I've heard this wonderful phrase from one Mr. Terence Stow, a big genius. He said the level of difficulty of questions, the best place to learn is for the level of difficulty to be just beyond what you already know. Suppose your set of ton of knowledge comes up to like a big building like this. What should you be looking to learn? You should look to try to solve a question just here. But I climb up, climb up, climb up, climb up, and then I'm here at my body of work. I know my knowledge. And then I say, hey, can I take one little leap, grab hold of this, therefore my knowledge base now new becomes this. And I don't want to shoot for this when I don't have any energy. I can't see it, I can't jump, I don't have a mechanism to go there, I get dispirited. I don't want to keep solving questions here. If they're too easy, I get bored. I might make some mistake, but they're not challenging. I want it to be challenging. I want to be challenging at a level where it's just beyond what I can solve. That is the level that will help me add one more thing and say, okay, now I know this. That is my favorite level of difficulty. Wonderful. So what are we going to do? What are we going to do at the end of this? We're going to do the Olympiad, and then at the end of the Olympiad, I'm going to say, hey, you've had fun doing this. You've had fun solving these questions. You've had enjoyed this process of learning new ideas. And I'm sure quite a few of you are saying, hey, this is all fun, but this is just 1 hour test and 1 hour discussion, and we do a YouTube thing and we're done with it. And I know several of you are going to end this and saying, look, I got 2 questions right, but damn, I know I could have got 5 right. Another day and I'm getting 5 right. I wish there was one more exam here to prove to myself that I'm capable of getting 5 right and not just 2. I know you're chomping at the bits to say that. So there is a mechanism. There's no point doing a bunch of questions where they're difficult and then you say, hey, this was difficult, this was fun, and then we're done. Then there's no mechanism to grab onto that new level of difficulty and say, now I've got that also. I'm very comfortable with addition. I'm very comfortable with multiplication. I'm super happy with division. I know fractions, I know decimals, but then you should be able to say, okay, now I'm better at handling these kind of non-routine, different, cranky questions also. So we're going to do a summer camp, which is effectively just this. I want you guys to get comfortable or get to know about that idea. We're going to have a nice long discussion at 11 a.m. immediately after this session is done. So please tell your parents to keep themselves free. It's a good Sunday morning. Ask them to sit next to you. We will answer questions and queries and discussions, all of that as well. And then we will discuss on what are we going to do with the summer camp. Summer camp is a 6-day, 5-day sprint on pretty much exactly what you've done today on PiMO'. Interesting questions, fun questions, challenging questions, beautiful questions, something that you can learn from. 1 hour hit and discussion. So we're going to do that. We'll discuss that at 11. But I'm not going to take too much of your time. I'm going to go to the next question. A 3-digit number is considered to be special if it follows the following properties. It is a multiple of 15. Brilliant. So I'm going to think about the 3-digit number as A, B, C. A multiple of 15. Straight away I know if it's a multiple of 15, it should be a multiple of 3. and should be a multiple of 5. Brilliant. Should be a multiple of 3 and a multiple of 5. Nice. With a multiple of 5, what do I know? I know this should be 0 or 5. The last digit should be 0 or 5, that I know. The multiple of 3, what do I know? I know this beautiful thing, but if I add all the digits, that should be a multiple of 3. So far so good. Let's go to the next condition. The 3-digit number formed by reversing the digits of this number is an even number. Reversing this digit. So I get myself C, B, A. This is an even number. Even number should end in 0, 2, 4, 6 or 8. That means this A should be 0, 2, 4, 6 or 8. Even number, simple condition, like that. Which is brilliant, except it can't be 0, can it? Because if it were 0, this will be a 2-digit number. So 0 can be eliminated. A has to be 2, 4, 6 or 8. Not just that, we said C could be 0 or 5. CBA is a 3-digit number. This cannot be 0. 0, 5, 6 is not a 3-digit number, it's a 2-digit number. So C cannot be 0 also either. Brilliant. So now we are getting somewhere. We have a 3-digit number ABC. A can only be 2, 4, 6 or 8. C can only be 5. Nice. So I'm going to make sure we have that. We have 3-digit number ABC. I'm going to write this as A, B, 5. I'm going to say A can only be 2, 4, 6 or 8. And the one condition we have not used so far is that this number is a multiple of 3. Brilliant. Let's go to the last condition. It does not contain the digit 2. Super. Even this is eliminated. So A can only be 4, 6 or 8. C can only be 5. And we have this number that has to be a multiple of 3. Or we are dealing with numbers of the type 4-5, 6-5 and 8-5. That's it. So I'm going to erase that part so that it doesn't interfere with the rest of what we are doing. So only 3 numbers, 3 types of numbers, 4-5, 6-5, 8-5. We have accounted for the fact that such to be a multiple of 5, that is done. If you reverse the digit, it's an even number, that is done. It does not contain the digit 2, it has been accounted for. We should remember that this can't be 2. We need to accommodate the fact that this number has to be a multiple of 3. That means the sum of the digits has to be a multiple of 3. So 4 plus 5 is 9, that's a multiple of 3. So this digit could be 0. 4 plus 5 is 9. If you add 3 to it, 4, 3, 5, that will be a multiple of 3. 4 plus 3 plus 5 is 12. 4, 6, 5. 4, 9, 5. 4, 0, 5, 4, 3, 5, 4, 6, 5, 4, 9, 5. All of these can work. 4, 0, 5, 4, 3, 5, 4, 6, 5, 4, 9, 5. All of them can work. 4 numbers are possible. 4, 0, 5 is a multiple of 3, multiple of 5, 15. 3-digit number formed by reversing digits, an even number. Yes, it works. It does not contain the digit 3. Wonderful. 6-5. 6 plus 5 is 11. 11 plus 1 is 12. So 6, 1, 5 will work. 6, 4, 5 will work. You add another 3. 6, 7, 5 will work. 6, 1, 5, 6, 4, 5, 6, 7, 5. 6 plus 1 plus 5 is 12. 6 plus 4 plus 5 is 15. 6 plus 7 plus 5 is 18. All of them work. 6, 10, 5 obviously can't happen. 8-5. 8 plus 5 is 13. 13 plus 2 is 15. So 8, 2, 5. But this can't happen because we cannot have a 2 in the middle. We cannot have a 2 in this number. And so 8, 5, 5 will work. 8, 8, 5 will work. Wonderful. So 405, 435, 465, 495. 615, 645, 675. It doesn't work. 855, 885. 855 is a multiple of 3. 885 is a multiple of 3. So all of these numbers work. How many numbers are there? I'm just going to have one look at the chat window to see if there's something there. How many numbers are there? 4 plus 3 plus 2, 9 numbers. 4 of these. 3 of these, 2 of these. 4 plus 3 plus 2, 9 different numbers work. Brilliant. Methodically, we can solve this. Nothing, no rocket science here. P plus 8, P plus 16 are all prime numbers. If P is less than 1000, what is the largest possible value of P into P plus 1? P plus 8, P plus 16 are all prime numbers. Interesting. P could be 2, 3, 5, 7, 11. I'm just thinking about prime numbers. But if P were 2, 2 plus 8 is 10. So P plus 8, P plus 16. P could be 2, 2 plus 8, 10. This plus 8, 18. These are not prime. This doesn't work. I'm going to put 3, 11, 19. 3 plus 8, 11. 3 plus 16 is 19. Yeah, that works. 5. 5 plus 8 is 13. 5 plus 16 is 21. 7. 7 plus 8 is 15. 23. Plus 8, plus 8. 11 plus 8, 19. Plus 8, 27. 13 plus 8, 21. Plus 8, 29. And so on. Less than 1000, I cannot obviously write all numbers. 3, 11, 19 are all prime. This works. 5, 13, 21 is not prime. A multiple of 3. 7, 15, 23 is not prime. 15 is not prime. 7, 15, 23, that doesn't work because 15 is not prime. 11, 19, 27. 13, 21, 29, not prime. I've got this. I've got only one answer so far. I'm already worried. Maybe there are not that many answers, that many numbers. 13 didn't work. I want to find one more number so that I can be confident and then build from there. So after 13, I'm going to think about 17. 17 plus 5, 25. 33. This is not prime, this is not prime. 19. 19 plus 8, 27. 27 plus 8, 35. This is not prime, this is not prime. 23. 31. 39, not prime. 29, 37, 45, this is not prime. I'm getting worried. I've tried so many prime numbers. Starting, if P is prime, P plus 8, P plus 16, at least one of them is not prime. In some cases, both are not prime. But generally, at least one of them is not prime. I'm beginning to get worried. I'm beginning to get worried so much that now I think this is the only possibility. And then now I'm going to say, okay, maybe this is the only possibility. I'll look to prove that. I want to find a pattern here. The multiple of 3, 5, 3, 3, 5, 3, multiple of 3, multiple of 5, multiple of 3, multiple of 3 and 5. I noticed that generally 3 and 5 come up trumps, but always 3 comes. The multiple of 3, 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 multiple of 3. So it looks like multiple of 3 is a problem for me. Always some multiple of 3 is sitting inside. Now I'm going to reverse this question, flip this question and say, hey, can I now look to prove that of P, I'm going to draw the number line. I have P here, P plus 8 here, P plus 16 here. Nice. I have a sense that this has got something to do with multiples of 3. Right? Wonderful. So I'm going to go in steps of 3. Right? Steps of 3. So P, P plus 3, P plus 6, P plus 9, like that. Or P plus 8. Subtract 3 from it, I'll go to P plus 5. Subtract 3 from it, I'll go to P plus 2. Likewise, P plus 16, subtract 3, 3, 3, 3, 3. If you subtract 5 3's, I'll go to P plus 1. Right? Why am I doing this? Because I want to think in terms of P, P plus 1, P plus 2. These are 3 consecutive integers. 3 consecutive integers, one of them has to be a multiple of 3. Any 3 consecutive integers. 5, 6, 7, 10, 11, 12, 15, 16, 17, 109, 110, 111, it doesn't matter. 3 consecutive integers, one of them has to be a multiple of 3. So P, P plus 1, P plus 2, one of them has to be a multiple of 3. Or P, P plus 16, P plus 8, one of them has to be a multiple of 3. Why? P plus 2 plus 6 is P plus 8. P plus 1 plus 15 is P plus 16. So P, P plus 1, P plus 2, one of them is a multiple of 8, multiple of 3. P plus 16, P plus 8, one of them is a multiple of 3. If these numbers are, one of them is a multiple of 3, they cannot be prime. So P plus 1, P plus 2 cannot all be prime. P plus 16, P plus 8 cannot all be prime. Why? Because one of them has to be a multiple of 3. If it's a multiple of 3, it cannot be prime. Is there any exception? Yes, there is a beautiful exception. What is that exception? 3. There is one multiple of 3 that is prime. So it could be 3, 19 and 11, where the P is itself a multiple of 3 but still prime. I have one number that's a multiple of 3 and prime, 3 itself. The only way P plus 8, P plus 16 can have a prime number among them is if P were equal to 3. Or, quite interestingly, this is not a possibility, this is the possibility. There is only one possibility of P such that P plus 8 and P plus 16, all 3 are prime. Therefore, P has to be 3. So, what is the largest possible value of P into P plus 1? What is the value of P into P plus 1? 3 into 3 plus 1, 9 plus 1, 10. P plus 8, P plus 16 cannot all be prime. At least one of them, or one of them, not at least one of them has to be a multiple of 3. If one of them has to be a multiple of 3, that cannot be a prime number. So, P plus 8, P plus 16 cannot all be prime, except if P were equal to 3, or P equal to 3 is not a possibility, it is the only possibility. Then we are through. Wonderful. Question number I think is 6 or 7, I don't know, I think it's 7. I'm going to go to the next one. The first digit is one of my favorite questions, a beautiful question. The first digit of a 4-digit number is equal to the number of zeros in the number. The second digit is equal to the number of ones in the number. Third digit is equal to the number of twos in the number. And the fourth digit is equal to the number of threes. Right? Number of zeros, number of ones, number of twos, number of threes. Brilliant. How many numbers have this property? Beautiful question and one of my favorite questions. First of all, we know it's a 4-digit number. Right? So what do we know? We know that the first digit is not 0. Right? That much I know, because otherwise it won't be a 4-digit number. So the first digit could be 1, it could be 2, it could be 3, it could be 4 and so on. It is not 0. The first digit were 1, that means this number has 1 0 in it. Beautiful, it has 1 0 in it. First digit were 2, that means this number has 2 zeros in it. First digit were 3, that means this number has 3 zeros in it. So 4, that's 4 zeros in it and so on. But straight away, the moment I think this, if it has 3, it should have 3 zeros in it. It should have 0 0 0. But it has already 1 3 in it. So this number cannot be 0. 3 0 0 0 doesn't work. 3 zeros, 0 ones, 0 twos and 0 threes, not 0 threes, there's 1 3 sitting inside. This doesn't work. This number cannot have 4 zeros. It's a 4-digit number. It cannot have 4 zeros in it, because if I put 4 here, there's only room for 3 more digits. So 3, 4, 5, 6, 7, 8 are all out. Or my first digit can either be 1 or it can be 2. Nothing else is possible. Now I am through. 1, 2, 3, 4. 1, 2, 3, 4. I'm going to put the first digit as 1 and first digit as 2. Brilliant. First digit is 1. That means this number should have 1 0 in it. Right? This is not that 0. Why? There is a number of 1s in the number. There's already 1 1. This is not 0. This could be 0 or this could be 0. I'm going to try to create that. I'm going to think about 2 numbers. Say 1 dash 0 dash or 1 dash dash 0. Nice. 1 dash 0 dash or 1 dash dash 0. This number has 1 0, 0 twos, so it should be 1s, 2s, 3s. 1 0, 0 twos, some number of ones, some number of threes. There has to be 1 3 in this number, at least. But this is not 0. If I put 3 threes in this number or 2 threes in this number, I don't have enough room. This is 1, this is 0. I cannot have this as 3, then I'll have 3 threes, that's not possible. I can have 1 3, in which case this has to be 3, or I can put 2 threes, there will be 2 3s, that's not possible. It has to be 1 3, in which case this is 3. 1 3 0 1. So 1 0 in this number, 3 1s in this number, only 2 1s are there. No 2s in this number, that works. 1 3 in this number, that works. But this one gives way, it doesn't work. 1 3 0 1 does not work because there's 1 0 in the number. 3 1s need to be there, but this number 1 3 0 1 has only 2 1s. This also doesn't work. Let's go to 1 dash dash 0. There's 1 1 in the number, no 3 in the number. There's only 1 0 here. Both of these need to have numbers. Right? How many 1s are there? I cannot say 1 1 is there because if I put 1 here, then there will be 2 1s. This number cannot be 1. It's not 0, it cannot be 1. It has to be 2, 3, something like that. I'm going to say, hey, let me put it as 2. One 0, 2 1s, 1 1 is already here, the other one here. 1 2, no 3s. This works, brilliant. We are through. 1 2 1 0 work. 1 0 in the number, 2 1s in the number, this and this. 1 2 in the number, yep, this is here. And no 3s in the number, yep, this works. Brilliant, done. So 1 2 1 0 works. I cannot have this digit as 1 3. If it says 1 3, all 3 digits have to be 3. Everything else has to be a 1. That's not possible. There's no 1 2 1 4. None of these work. 1 2 1 0 is the only possibility starting with 1. The starting digit can only be 1 or 2. Starting with 1, there's only one number. Starting with 2 is even simpler. Even simpler. Why is it even simpler? Because if you start with 2, there have to be 2 zeros in this number. And so I can say, hey, 2 zeros need to be in the number. This number already has a 2 in it. And so this is the number of zeros, the number of 1s, number of 2s, number of 3s. This number already has a 0 in it. So this one cannot be 0. This number cannot have 0 2s. It already has a 2 in it. So if you have to have 2 zeros, they have to be here and here. Now let's think about this number. This number has 2 zeros. Yeah. 0 1s possible. That means this will not be 1. This, if I put 1 here, it will have 1 2 in it, but then this will have to become 1. That doesn't work. If I put 2 here, 2 2s in it, yes, that works. 2 and 2. No 3s in it. Done. 2 0 2 0 could also work. Just trial and error, but with being scientific about it. Beautiful question. 1 2 1 0 and 2 0 2 0 both work. If you pause and think about this question, the sum of the digits of this number should always be 4. The number of zeros, number of 1s, number of 2s, number of 3s, if you add all of that, then it should be 4. Because only 4 digits are there. These should always add up to 4. That's another thing to keep in mind. The starting digit is either 1 or 2. It cannot be 0. It cannot be 3. Put it as 1, figure out every possibility. If you put it as 2, figure out every possibility. 1 2 1 0 and 2 0 2 0 both satisfy all the conditions given here. The conditions being the first digit should be the number of zeros, second one should be the number of 1s, third one should be the number of 2s, last one should be the number of 3s. So 1 2 1 0 and 2 0 2 0 both work. 2 numbers are possible. Excellent, excellent question. Lovely. I'm going to go to the next question. 6-digit number 52583A is a prime number. Find the single digit number. Oh, beautiful question. One of my favorite questions. Why? It's a prime number. That means it's not an even number. It's a 6-digit number. It's not an even number. So straight away, our A cannot be 0, 2, 4, 6 or 8. Not possible. All of these are out. A can only be 1, 3, 5, 7 or 9. The moment I write this, I know it cannot be 5. Why? Then it will become a multiple of 5. So all I have is to say this number could be 525831, 525833, 525837, 525839. One of these should work. This should be, one of these should be prime. Let me see if this is prime. How do I check whether such a large number is prime? I know based on what I know already. I'll add all the digits up. 5 plus 2, 7, 7 plus 5, 12, plus 8, 20, 23, 24. 7, 12, 20, 23, 24. Sum of the digits is 24. Why am I doing sum of the digits? Because I want to verify for multiple divisible by 3. For checking for 2 and 5 is very easy. I've already done. Next I'll check for 3. Sum of the digits is 24 here. This number is not prime. It's a multiple of 3. Instead of 1 I put 3 here. So sum of the digits will be 26. This could still be prime. 24 plus 6. This is sum of the digits will be 30. This is not prime. How do I get 30? I can add everything up. 5 plus 2, 7. 7 plus 5, 12. 12 plus 8, 20. 23, 30. How do I get to 30? Instead of 1 I put 7. I've added 6. 24 plus 6 is 30. Instead of 7 I put 9. So this will be 32. Straight away, first thing I had A as a digit 0 to 9. 5 went off. I have only 5 remaining. This went off. I have only 4 remaining. These two are multiples of 3. I have only 2 remaining. 525833. 525839. I know these numbers are not multiples of 2, 3, 5. Maybe they are multiples of 7. Maybe they are multiple of 11, 13, 17, 19, 101. I'm in trouble. I got everything eliminated, only 1 was remaining. I would have been very happy. But hey, I can still get wrong. I want to find a number that's a multiple of, maybe one of these is a multiple of 7 or 11. My life becomes easy. Let's see. 7 is tricky. 11 test of divisibility is easy. So let's try with 11. 5 plus 5 plus 3. 5 plus 5, 10 plus 3, 13. 2 plus 8 plus 3, 13. You know, test of divisibility by 11. Find even portion digits, odd portion digits, subtract. 13 minus 13 is 0. I'm loving this because this number is a multiple of 11. I know it's number a multiple of 11 because the test of divisibility works. That means I've eliminated everything except this. It is not my problem to worry whether this is prime. This will be prime because the question is saying so. The 6-digit number 52583A is prime number. A cannot be 0, 2, 4, 6, 8. A cannot be 5. A cannot be 1, 3, 7. A can only be 9. This number will have to be prime. That's what the question is clearly saying. So my answer A is 9. All I do is eliminate even numbers, eliminate multiples of 5, eliminate multiples of 3. I'm left with only 2 possibilities. Out of 2, luckily for us, this number is a multiple of 11. Game over, done, through. So A has to be 9. Getting some question, any formula to solve these type of questions? Of course not. Formulae are boring. We pit our wits against these questions, make us try solving this without knowing any formula, try different method. That's the beauty of these questions. So no formula, nor should we be using them. What is the question number? Question number is either 8 or 9. I think it is 9. Rene Eggers, will the medium of communication be completely in English? Yes, it will be. Yes, it will be. Sometimes it is unfortunate, but it will be in English. It will be simple English. It's not we're not trying to establish how great our English is. We'll communicate super crystal clear. We'll always have beautiful detailed slide solution. But the communication mode will be English. Wonderful. I'm going to run the next one. In Alpha School, 11 members of their Kabaddi team participated in a tournament. Ram scored 1/5 of all the points. The Ram scored 1/5 of the total points. David scored 2/7 of all the points. David scored 2/7 of the total points. Rahim scored 22 points. Rahim scored 22 points. The rest 8 players each scored 3 or fewer. 8 others, each of them 0, 1, 2 or 3. 3 or fewer. What is the maximum number of students who could have scored 0 points? Suddenly, if you've gone somewhere else, what is the maximum number of students who could have scored 0 points? Wonderful. 1/5 of total, 2/7 of total, and then 22, and then the other 8 put together. What am I going to do? I'm going to say, hey, all of them put together, this other 8 put together, I'm going to call it as X. All put together is X. So what do we have with this? So I have 1/5 of total plus 2/7 of total, 2/7 of total, plus 22 plus X equal to total. Total number of points are there. 1/5 is by one guy, 2/7 is one guy, 22 is one guy, and then there is the remaining adding up to a total. I'm going to find this 1/5 plus 2/7. The LCM is 35. 7/35 plus 10/35 times total plus 22 plus X equal to total. So these two guys, Ram and David together, score 17/35 of total, and then the remaining is 22 plus X equal to total. Brilliant. Now I am through. How? 17/35 these two guys account for. Out of a total, 17/35 of it those two guys account for. The remaining should be 18/35. It's like 35 parts are there. Out of the 35 equal parts, these two have taken 17. The others should take the remaining 18. Right? So I know my 22 plus X is 18/35 of total. A beautiful idea. We're clearly sitting inside this, the number of points. This answer, 22 plus X cannot be 14.9, cannot be 17.3, cannot be 48.11, cannot be 37.65. This is a nice integer. Or this side should also be a nice integer. Brilliant. That means 18/35 times the total should be an integer. There's a 35 in the denominator. That has to get cancelled. Otherwise, I'm in trouble. Or my total should be a multiple of 35. Otherwise, this won't be an integer. Or my total should be either 35 or 70 or 105 or 140 or something like this. Some multiple of 35. If I put total equal to 35, then 22 plus X will become 18 if total equal to 35. That doesn't work. Why does it not work? This X cannot be negative. Then, so total is not 35. If I put total equal to 70, 18/35 into 70 is 18 into 2, 36. 22 plus X equals 36. Maybe that is possible. 18 into 2. Next step what will be? It will be 18 into 3. 22 plus X equal to 54. 22 plus X equal to 72. These are all possibilities. Nice. Now I know that this 22 plus X could be 36 when total is 70. 2 times 35. 3 times 35 will be 54. 4 times 35 will be 72 and so on. What becomes the most interesting part? 22 added to this X is 36, or our X has to be 14. How do I get 14? 36 minus 22. 22 and then X more takes us to 36. What will be this scenario? 22 plus X is 54. X is 54 minus 22, which is 32. We can find another number here and so on. Now this X, the total number of points got by 8 different people. The most beautiful part in this question comes here. 8 different people together have got X. But these 8 people are useless. They've all got, each of them has got 3 or lesser. I won't say they are useless. They are not scoring points. Maybe it's not the center forward. Maybe he's a defender. He's very powerful, useful, but he's not the point scorer. And useless is the wrong word. If all of them get 3 points, the maximum they can get. If all of them get 0, they'll all get 0 together. All of them get 3 points. The total maximum can be 8 into 3, 24. Or it cannot be 32. It cannot be the next number. None of that is possible. If all of these fellows, 8 people put together, can score a maximum of only 24 points. They could not have scored 32 points or even more than 32. Or these 8 people put together should have scored exactly 14 points. Now we are through. So these 8 people together scored 14 points. We want the maximum number of students who could have scored 0. If this 14, lots of people should have scored 0. That means very few of them should have scored up to 14. Get a few to get maximum. Unless the maximum they can score is 3. Let me say the first guy gets 3, second guy gets 3, third guy gets 3, fourth guy gets 3. If the fifth guy also gets 3, it will become 15. 5 into 3 is 15. That's not possible. There are only 14. The fifth guy gets 2. Put the maximum possible points for as few guys as possible. Remaining all get 0. 3 plus 3 plus 3 plus 3 is 12. 4 guys get 3 each. Fifth guy gets 2. Best case scenario to get to 14 points. In which case, the last 3 got 0, 0, 0. 8 people should be there, of which we are assuming 5 of them bring all the points. 4 into 3, 12, plus 2, 14. 4 guys get 3, 1 guy gets 2, 14 points get accounted for. If you get 4 zeros, it's impossible. If 4 people had got zeros, the remaining 4 couldn't have got to 14 points. That's not possible. 5 people together can get to 14 points, not 4. So 5 people together get to 14, 3 people get 0. The maximum number of students who could have scored 0 points is 3. There are more than 3 people getting 0 points, then that total can never be 14. That total is not 14, the rest of the conditions won't get matched up. Absolutely beautiful question. Based on that idea that the total number of points has to be a multiple of 35. The total number of points has to be 35 into 270. If it is 35 into 270, then all these remaining people together get 14 points. That is the only possibility. Their total cannot be 32. Their total cannot be more than 24. So use that and then come back and simplify and do everything. Wonderful, wonderful, delightful question. I think we're pretty much at the last question. Yep, wonderful. So I think I've spilled over on the time axis a little bit. We've probably gone beyond our scheduled allotted time. Many thanks for hanging in. Lovely, lovely to see so many students with so much enthusiasm. It is a delight to be speaking to young students. I'm sure you're all going to learn tons of things. And so, once again, if you have your parents around you, please call them over. This part they should listen to as well. What are we going to do in the summer camp? Summer camp, we're going to do it in summer. That much is obvious. The dates are mentioned here. You can find the dates, this screenshot, this will be available to you. There are 2 batches, one for classes 5, 6, 7, one for 8 and 9. Okay? So the date and time are available. What are we going to do? We're going to say every day we'll take a test very much like what we did in PiMO'. And then every day we're going to have this 1 hour discussion at the end of it. What is special beyond this? What is the more fun thing beyond this? What is the juicier thing beyond just meeting this? We'll have this class not on YouTube, but in a nice gathering, all online. We're living in the online world. If we teachers started off on our online journey when we were 25. All of you guys have started on your online journey when you're 8, 9, 10. And maybe the kids, your younger sisters and brothers will start it when they're 5, 6, 7. Completely online. But it's a nice group. You will all get to know all your friends. So Purnima will know Puneet Singh, will know Lata, will know Nirja Gopinath, will know Next Gen Magic, will know Nikhilesh. So all of you will get to know each other. So it's a lot of fun. We have a chat window during class. We have a discussion about this and that. So each day we'll come together and do a bunch of classes. Sorry about that. We'll do a bunch of questions like this, like usual. And then like what we did now, and then discuss them, and then learn some new ideas. We'll learn solving techniques. We'll know how to think about different things. We will not teach you tons of new theory. Theory is covered. Theory your school will do more than anything, better than any other scenario. We will teach you new thinking techniques, not solving techniques. And like these questions that we discussed, The question with the number of digits is the number of zeros, ones, twos, and threes. That's a delightful question. It's a fabulously interesting question. I want to sit and do 2 more variants of this question. I want to think about maybe there is a 5-digit variant of this question I've not thought about. Number of ones, zeros, ones, twos, threes, and fours. Maybe we have missed out on that. Maybe we should think about that. That is the fun discussion to have. That is something that I want to have with all of you. So I want to have we've created this summer camp with the idea of saying, hey, good, wonderful questions, maybe 10 every day, a 1 hour discussion of these 10 questions, a 10-minute hi, hello, chat conversation. I feel our school system focuses a lot on theory and the mechanics of learning. So all of you want to learn to know what is the idea, what is the formula, and how do we substitute this. I want to throw all of you into the deep end and say, hey, there's no formula for this. There's no defined method for this. You figure it out. You go and say, hey, I don't know how to solve this. I will try this method. I'll substitute k equal to 12. I'll substitute k equal to 13. I'll put 14. I'll put 15. I'll put 16. Maybe somewhere I'll get lucky. Maybe I'll keep trying. Maybe I'll look at this question and say, hey, I don't really know how to solve this. Maybe the total number of points is 70. Maybe it's 105. Maybe it is 140. I don't know. I'll keep trying. So there are several occasions where we say, hey, I don't know the method. Let me just figure out by substituting different things. I want to build a toolkit where you learn how to figure out different ideas, different templates, different new concepts, new fundas. Not give you concepts on a platter. And the concepts on a platter era is done. I don't want to do that anymore. So I'm going to throw you into the deep end and say, hey, try different things, try newer ideas. Right? So any questions from parents, any question that you have on what the summer camp is going to contain, what is the idea behind PiMO', the rest of it, please ping us. Please ask us on our chat window. The results, we will give you the results soon. There is bunch of students have performed spectacularly well. This is not the first year we're doing the Olympiad. We did a Olympiad and summer camp last year. The summer camp was fantastic. Some of the students loved it, that they came for multiple iterations of it. Some students attended multiple summer camp because it was a lot of fun. It is not a day-long thing. It's a couple of hours. It's not where you sit down and listen to tons of theory. It's challenging question. The question taking part is fun, but then you hardly score more than 5, 6. So the discussion part is even more fun. The chatting with friends is juicy. So it's one of those things that you can easily slip into, even in your summer mode of fun. And so definitely do that. Parents, if you're sitting there and you want to know anything about the summer camp, do reach out to us. I'm available here to answer any question that you put on the chat. Or you can always reach out to us on phone, email, WhatsApp, every other mechanism that's available. Right? Puneet Singh is saying, I'm already signing up for that. You should. It's a lovely course. And I think there's a beautiful mechanism to sign up early. If you sign up before March 5th, there is a discount as well. So you should grab that and then go forward with them. Right? Wonderful. We've done this session, we've discussed this. I'm going to give you the results as well. Before that, I should probably know about our team at PiVerb. My name is Rajesh, so I'm the teacher. The person who runs this thing is Avinash. And then the people who work with Avinash are the 3 people mainly, Bala, Lakshmi Narasimhan, and Raghu. And Bala handles all the PiVerb technology and the bits and bobs that make the system work. Raghu handles all the content along with me. Raghu and I work with the content. Avinash runs PiVerb. Lakshmi Narasimhan handles all our partnerships. So there are several people who work with us, but the 5 of us do most of the meeting with parents, meeting with teachers, running the YouTube sessions, all of that. And so you will meet all of them in some form, maybe on Zoom when you attend the summer camp, when you on our live sessions, somewhere there. But that is the team. And I'm Rajesh. I'm the teacher. I'm an engineer. I've been fascinated with math for a long time. I loved doing these non-routine questions when I was in class 8, class 9, class 10, when I came to city for the first time. I grew up all over the place. And I was fascinated by non-routine questions. And then I was fascinated so much that after the non-routine question thing, the natural thing, because I was comfortable with numbers, was to get into JEE coaching and all that. But back then, the JEE coaching thing was not a 7-year, 6-year affair, only a 2-year, 11th and 12th thing. And I finished my engineering from IIT Madras, and then I did my MBA from Bangalore. Jumped back into teaching about 10, 12 years ago. So that is my background. You'll probably get to know the background of rest of the guys here are very, very interesting characters. A lot of guys who love mathematics, love dealing with young kids, all of that. I know you're fascinated with scores. I want to de-emphasize this desperate need to get to the scores. You can sign in and get to the scores. I have a son who can't wait to see scores. And I keep telling him, look, how does it matter? How does it matter? It doesn't matter. You've had fun, you've learned a bunch of things. It does matter, but it doesn't matter so much that you're anxious to just look at the score. That number will say 9 or 12, and it's not going to move the needle anywhere. But if you've understood two ideas better, that is the thing. And in our country, we have a scarcity economy. We have a mechanism where all of us scramble for everything all the time. It's not healthy. And so I want you guys to consciously de-emphasize score for every avenue you have. It's an Olympiad and a competition. I get that. I get that. Believe me, I get that. I've written competitive exams part of my DNA, and I cleared one to go do an engineering and did one more to do an MBA, done a bunch after that. So I get it. I get that we are hard coded to be functional in a scarcity economy, no doubt about it. But at some point of time, you have to say, look, I enjoyed this, I learned this, I had fun with this, I figured out this. That one idea that Sir said, oh my God, I wish I had thought like that. That guy who can't put in the chat window that he did by this different method, mind blowing. Why didn't I think of that method? Brilliant. I learned this method, that idea, this fun, this concept. That is what you should be scrambling for. You're young people. So don't be slave to a 13 and a 12 and 11 and all of that. Expand your canvas and say, I'm going to learn tons of new ideas. And that's where the thrill is. Fine. So once again, any questions, queries, scores, please ping me on chat. We will answer all of those queries. How do you check your scores? Log into math.piverb.com, click on the Olympiad test, and the below screen will appear. This should appear. I've not tried this. And then click here and put view results, you'll know your score. Not rocket science, you'll be able to. I think the scores, I was super keen that the scores not be released before the discussion. I don't really worry about how many people get 9 or 12 or 16 or 15 or whatever the mechanism is. I want to make sure that all of you sit here and listen to the learning part of it. And so you've taken the test, you've had fun, enjoy the learning part as well. But hey, this is available, you can grab it and take it. Some wonderful prices. I think Avinash and Raghu and Bala and Ellen have really come up with a bunch of things that are very relevant for you guys. And I would have said, look, buy this book. Make them learn mathematics. And I said, look, they're going to learn mathematics anyway. Let's give them something else that they'll be thrilled with. All the students winners will get winner certificates, and Wall of Fame mention on Facebook. They will have access to the master class for 10 classes. It's a wonderful course to learn mathematics. Winners will also get a beautiful, delightful set of speakers. Anil Rao, fantastic performance. I saw the dashboard, I saw your the score. Fantastic, fabulous. And so it's a brilliant score and performance. Hat tip to you, man. I hope you go long and far and learn lots of mathematics and do really meaningful things to the world. Enjoy yourself learning as much as possible, as widely as possible. Fantastic congratulations and best wishes from all of us at 2IIM, particularly me. Wonderful, great effort. Keep at it. Hope you go far. All of you will get a certificate of merit and a winner's certificate. All the students will get. We will send it out digitally to all of you. This will look very much like this. So please take the time out. Go check out the scores. But more than the score and the mark and the +3 and the -3 and negative and positive and all of that, make sure you spend some time in understanding the solutions for the 3 questions that didn't fall in place directly, in getting the funda clarified, in discussing with friends and parents and saying, if this question was brilliant, I'm going to throw it at you. Why don't you have a chat? That question on 4 digits, the first one being the number of zeros, number of ones, number of twos, number of threes. You have a 70-year-old grandmother, you can give it to her. If she's curious, she will try it. There needs to be no toolkit. You don't need to know any formula to try it. You just write down different things, you can get to the answer. It's a lovely set of questions to discuss with anybody and everybody. And so please do that. Engage with the content. Learn to figure out new ideas. Everything else is incidental. It will fall in place after that. Wonderful. I'm just having a look at the chat window. I'm pretty much done. Kaushik Reddy, I've already registered for the summer camp. Brilliant, brilliant, brilliant. I'm looking forward to seeing all of you. As I said, I'm at my happiest when I'm discussing math with young kids. So I can't wait for the summer camp to begin. I can't wait for the summer to begin. I'm done with school. I don't know how you guys are feeling. I feel like this year the school should be shorter, but unfortunately the school year is longer in several places. And I can't wait for your schools to be over and to be done with online and signing in and signing off on part online, part offline, like finish it off already. And I can't wait for the summer and the vacation and to begin. And then within that summer camp should be a lot of fun, ton of fun. Right? Mona Sumanta, quite genius, must be a listener. Yeah, listening is a brilliant, brilliant attribute. Anandi Venkat, cost of a summer camp is about 2,500 rupees, not much. Karan Adlaka, on average, how many questions will be? 10 questions. 10 questions for the class, 10 questions for the discussion. It will be power packed. It will be like this session. So it will be at a rapid clip. It won't be, I firmly believe that the math and discussion learning is fun. So we won't pad it with anything. 10 questions will be fun like this, but challenging. As I said, the level of difficulty in my mind should be just beyond what you're already comfortable with. That's when you grab a new idea and put it in your box. And so that will be the plan. Hit like, subscribe, click on the bell icon, do the whole shebang, share, spread the word about us. We are young, we are energetic, we are super curious, we're super enthusiastic about practically everything we do. There's nothing that we like better than talking to young students and engaging with them with good content. The PiVerb channel has a bunch of brilliant, outstanding questions, so you should have lots of fun. If you enjoyed PiMO, then it's no-brainer enjoying the rest of the thing. We do a full year course as well where we do tons of questions just like this. So my biggest peeve with our entire mathematical education process is that, hey, it doesn't push students hard enough to learn new ideas, to figure out new fundas, to not know the answer and grapple with it and substitute and to just go mad thinking they're this close to the answer but it's not falling in place. And I want to create as many contexts as possible where young people like yourself are pushed to do this. What I want you to bring to the table is tons of enthusiasm and a complete switching off from the idea of getting 3 or 4 or 2 or 1 and hopping onto the idea of saying, hey, I didn't know this. I just simply couldn't think like this before. Now I can. We're going to change the way we operate and think about these questions. That is the biggest objective of PiMO, summer camp, full year course, the whole shebang. So I want you from day one to be indifferent to marks and scores. Right? So this last word on this, the scores, I've seen the scores. I've seen the sum total and a snapshot of scores. If you've got 3 questions right, that is phenomenal. You're probably in the top 15-20% of people who have attempted this. And the people who have attempted this are among the ones who are more comfortable with mathematics. So if you've got 3 questions right, you're probably in the 90th percentile or higher, much higher, probably 95th percentile. If you've got 3 questions right, you're probably among the top 5% of students. And so it's already a brilliant place to be in. But our country is huge. 5% is not enough. You want to make sure that you have the toolkit to go to 1%, 2%. So the marks are, it's not easy to score this exam. I know several of you will be getting 90 out of 100 and 45 out of 50 in your school exams. But you still might have scored only 3 correct out of 10 in this paper. It is completely all right. And 3 questions out of 10 right is a wonderful performance. It's a delightfully brilliant performance. It's delightfully brilliant. 2 questions is great. Delightfully brilliant and a starting step. I'm very much interested in saying, hey, I like math. I get this. This is fun. Let me learn new ideas. And not worried about 3 or 6 or 9 or whatever. I'm not worried about that. Nor should you be. Parents, a big request to all the parents out there, engage with us on the content basis. Reach out to us if you have anything to clarify. But please don't. Any parent, please don't come back and tell us our scores are, my son is getting only 2 questions right. My daughter is getting only 3 questions right. If they get 2 questions right, I'm thrilled. I'm happy. I'll be like, look, this is working. Somebody, they're getting 2 questions right, hanging in there to listen to the remaining 8, knowing the answer for maybe 6 out of 8 within 1 hour discussion, getting comfortable with 3 more ideas. They will learn to figure out. If they don't learn to score marks, we're all better off for it. And so With that, I'm going to sign off. Any questions, queries, we will discuss that. We will answer those questions. Any which way, you can reach out to us on multiple platforms. So all the other platforms that we are present in, you can reach out to us on phone, email, WhatsApp, through our website, chat, several platforms. So if you have any queries, questions on the summer camp or on the PiMO or on the numbers, please reach out to us. I'm not going to say why this child has got this many marks or how come this exam is difficult that we've got only 2 right. None of that. The exam is meant to be difficult. It's meant to engage with the content, learn 2 ideas and have fun, not for scoring marks. Marks are completely incidental and there's every possibility that the scores are much lower than what you have expected them to be. Every possibility. I don't want to have a bunch of disappointed students or disappointed parents. I'm giving the disclaimer straight away. I have seen the dashboard. The marks are not anywhere close to what the students think they are. When students are likely to do an exam and say this is easy, this is doable, I could get 100, and then they come back and they may get 25%. That doesn't mean that 25% is wrong. That doesn't mean that they're saying I will get 100 is wrong. It is just one of those things that we are able to teach our kids saying, hey, it's all right if you have got only 20%. That's how tough this exam is. You can still learn something from it. Then you tap them on the shoulder, give them a pat, and then push them along to the next thing. So parents, please be informed that the scores are much lower than what students are likely to have seen in their life that far, and that is completely all right. Wonderful. I will sign off with that. Ciao. Where to check the marks? Somebody said, where to check the marks? I think we had covered that. Click on math.piverb.com, click on the Olympiad test, and the below screen will appear, and then you can click on view result and see your performance and what you've got right, what you've got wrong, the whole shebang. Once again, the marks are very likely, it is very likely the marks are lower than what you're used to seeing, and definitely lower than what you're used to seeing, and quite likely they're lower than what you thought you would got even 20 minutes ago. It doesn't matter. As getting 2 questions right out of 10 in this is spectacular. And these are tough questions, unusual questions, atypical questions. So it is important to hang in there and not worry about the marks. Right? Best wishes all of you. Have fun. I can't wait to meet all of you during the summer vacation. So, just a summer camp, last details. I'm going to leave the screen here so that you can see the details very clearly. I don't think there's much for me to add. You can go here and register. You can click on the description and register. You can know all the details available here. It's an expanded version of what we did today. Best wishes. Ciao.